Welcome to the Gone Fission Podcast, your one-stop source for news about the emerging nuclear renaissance and environmental cleanup of Department of Energy sites across the nation. Now, here's your host, Michael Butler.
Hello, and welcome to the Gone Fission Podcast. Today is Monday, October 28th, 2025. Today we're exploring the expansion of nuclear power with a major company whose name is synonymous with design and construction of nuclear power plants. It's a name we all recognize. It's a company called Bechtel. Over the decades, Bechtel has built an impressive track record of leadership and achievement in nuclear power, infrastructure, and more. Since its founding in 1898, the company has helped customers complete more than 25,000 projects in 160 countries on all 7 continents. Today we're going to take a close look at what Bechtel is doing to promote the nuclear renaissance with advanced reactor technology both in the U.S. and abroad. We'll talk with a Bechtel executive about the company's partnership with Bill Gates in Wyoming, and we'll discuss Bechtel's role in building the first ever nuclear power plant in Poland. But first, if you're a regular viewer of this podcast, I invite you to subscribe. You'll support continued production and receive notification when new episodes are available. It's free. Do it now. You may recall a few weeks ago, I introduced you to a man named Mike Deane, who has gained internet fame as the Nuclear Average Joe. Mike is a regular guy who's taken an interest in nuclear power and has taken the time to educate himself about this energy source. In the process, he's become a big proponent of nuclear, something he thinks others would do too if they just took some time to study it like he has. In this and coming episodes, Mike Deane will be a regular contributor to the Gone Fission podcast. Here are his thoughts for this week.
Let me tell you a story on how I became the Nuclear Average Joe, how I went from Average Joe to Nuclear Average Joe. Many years ago, there was a client of mine that was seeking support for a glove box application, and at the time, the only glove box I knew of was the one inside of my Chevy pickup truck. And I had to ask, is this for an automotive application? Is this for a car or a truck? Is this a glove box inside of a car or truck? And it certainly was not. And it was pretty comical, the reaction I received from the chief engineer at the time. And at that moment, when I realized what it was, which a glove box is simply a box with gloves inside of it that protects someone outside of that box from the hazardous material that might be inside of it. Anyway, it's within national labs. It's a nuclear application. It's an application for many other industries, materials, so on and so forth. But that got me into this space. I wanted to know everything there was to know about what glove boxes do, where they are, which national labs have them, what the national labs are doing with it. And that led me directly into nuclear power, how it works, why it's beneficial. Was it easy to get here? No, not at all. Many books later, many conversations with my mentor, with many stakeholders at nuclear power plants, so on and so forth. But folks, it all started with a simple conversation. It could start with you too like that. Maybe it's this video. It might be someone that you bump into over the weekend at the grocery store. You never know. But man, has it changed my life? Has it changed my family's lives? I mean, it's been a remarkable journey. Mind you, I have no connections to nuclear outside of what I've done and what I've created here. The way I put it, folks, is the nuclear industry adopted me. And, I like to think I'm the nuclear industry's favorite stepson, if you may. Because I don't born into the industry per se. So anyone can do it. Keep following my journey. I'm excited, and let's make it a great day, nukes. Till next time.
Our guest today is Ahmet Tokpinar. Ahmet is the Principal Vice President and General Manager of Bechtel's nuclear program. He has a big job with responsibility for Bechtel's nuclear power program globally. Welcome to the podcast, Ahmet.
Thank you, Michael. Thanks for having me.
Well, we're very glad you're here. We've got a lot to talk about today, so we'll jump right into it. Of course, Bechtel has an excellent reputation in the nuclear industry as having been involved over the decades in design and construction of nuclear power plants. And today you're kind of straddling the line between the traditional plants that we're used to in the U.S. and around the world and the advanced reactors that are ushering in the nuclear renaissance. And Bechtel recently supported Georgia Power in bringing its 2 units of Vogtle online in Waynesboro, Georgia. And this is now the largest nuclear plant in the United States. And Vogtle is what we consider to be part of the traditional nuclear technology, the larger 1,100, 1,200 megawatt reactors that we're used to seeing on the landscape around the country. But given the time frames and for construction and the costs involved in these plants, what do you see for the future as far as utilities continuing to build these large-scale reactors? So will there be more of them after Vogtle?
I believe very strongly that there will be more. I think we have an environment in the U.S., a high demand, primarily driven by needs of AI computing, heavy manufacturing, a very bipartisan approach to nuclear power. So, the stars are aligned. There are good incentives from Department of Energy, whether they're investment tax credit, DOE loan guarantees. We're in active discussions with potential customers, U.S. government, and I do believe in the next year or so, we will start hearing more from utilities with their plans to build gigawatt scale. The one thing I want to clarify, they are traditional, but when you look at the AP1000, it is an advanced light water reactor. And then you look at the advanced reactors, there are 2 groups. There are groups of small modular reactors that are light water reactors, and then you have more advanced reactors that uses different mediums for cooling, like sodium, high temperature, the gas, and other liquid metals. So, they're all different. The advantage of the AP1000 gigawatt scale is, as you mentioned, we jumped in the middle of construction in October 2017. I believe we were the 3rd EPC contractor. It was a really challenging, tough job. We turned it around. We finished the project. Now it's done. It's first of a kind. Risks are retired. There's a complete design, what we call the Unit 4 reference design, that is the standard. So for the next customer in the US, you're literally replicating what was designed and built at a different site with site-specific, of course. So the primary risk on nuclear projects, when you look in the past, mobilizing and starting construction before design was completed. And that was the lessons learned on Vogtle as well. And all other designs, the SMRs, advanced reactors, they're very novel concepts, but they're still in the design phase, and some of them will get a chance to build their first demonstration units at the end of this decade. And then there will be more replication in the 2030s. That market will start picking up. But between now and then, there is no other technology that is where, the AP1000 is. So There's a lot of interest. Economies of scale is there. The risks are known, and we know how to mitigate, plan, and build far better than the Vogel results.
Mhm. Well, let's dive into the topic of costs a little bit more. Craig Albert, who's your chief operating officer, has called cost the elephant in the room when it comes to construction of new large nuclear projects. The two units at Vogel reportedly cost over $10 billion to complete. And so when it comes to advanced reactors like the small modular reactors, proponents point to the fact that these units can be less expensive and are considered safer and more reliable than some of the larger units. So what's your view on that, and how would you rate the advantages and disadvantages of the new versus the more traditional larger reactors?
I think if you are a utility and your need is at gigawatt scale, you're always better off buying and installing a gigawatt scale reactor, because the economies of scale, building one versus 300 megawatt, is going to be cheaper on a levelized cost of electricity basis. If the application, if you're replacing a retiring coal plant at 400 megawatt electric, you don't need a gigawatt scale. You need a smaller unit. I think it depends on the needs and its application, not necessarily just the cost element. Obviously, one advantage of building an SMR one at a time is the capital requirements is not going to be as extensive. The financing is going to be easier. But today, they're not at equal level playing field today, because the Westinghouse unit, the gigawatt scale, is designed and built. Mm-hmm. The rest of the SMRs, advanced reactors, are not. So at the end of the decade, they will be where the gigawatt scale is. Then you can do a pure economic comparison. And the first ones that are being built today, between the different technologies, the first ones are going to be expensive. Then the cost curve, you have multiple builds with replication of a standard design, will come very fast. Just like the gigawatt scale, when we build the next two and then two more later, we will see the cost down significantly.
Well, Bechtel has advocated having the government assume more of the financial risk for some of these first mover projects like small modular reactors, and is something that you say other countries are already doing from a government standpoint to help promote the development of this technology. What would government support look like in the U.S.? What do you want to happen, and why is this kind of help needed?
So I look at it, I think the government is already doing a lot, and I just want to make sure that they take the credit for what is on the table today. We have two advanced reactors that are receiving 50% grant from Department of Energy, Natrium with TerraPower, X Energy with Dow, to build their demonstration reactors. That's a significant support. There are significant tax credit benefits, up to 50%, which is for those that are under construction by 2032. So that's why you see a significant rush for these customers to expedite their plans, permitting, and get there as quickly as possible. It's a huge benefit. DOE Loan Program Office has vast resources and very flexible in terms of tailoring loans to customers willing to build gigawatt scale reactors. And then you have the hyperscalers, that are willing to pay a premium on power purchase agreements. So we're looking right now with the different stakeholders. Does the industry need more, or is that good enough? I don't have the answer yet. The cost, yes, that is the elephant in the room. Building a gigawatt scale is very expensive. The first two are going to be more expensive. It will come down significantly. So are there things the US government can do maybe for the first two or first four units? I don't have the answer yet. We're right now in the middle of analyzing, talking to the US government, talking to utilities and technology providers on the gigawatt scale technology that is built. It may be very little.
Mhm. Well, you mentioned the Natrium demonstration plant. You're partnering with Terra Power to build that plant in Wyoming, and of course, Terra Power is a Bill Gates company, and he's well known for pioneering in technology. Give us some background on that Natrium plant and how do you think it'll contribute to the nation's energy future, and what Bechtel's role is in that plant.
Yeah, we're very proud that Terra Power selected us to be their EPC partner, and they had the foresight to get us engaged from day one, very early when they were at a pre-conceptual phase of their technology development. It is a very novel technology. Sodium technology was used back in the 50s and 60s. It enables low pressure design because the boiling temperature of sodium is very high. The risk of accidents is minimal, and you don't need large containment walls and heavy wall pipes. It's a far simpler system with less redundancy, passive cooling, natural circulation. So at the end, once we finish design, it will have less commodities to install, and it will be easier and cheaper to build over time. It's going through its design. We're complete with preliminary design of all the systems. We are jointly designing the plant with them. They're focused on the key nuclear aspects. We're focused on the physical infrastructure of the power plant. We were mobilized at the site last year with groundbreaking, building the testing facility that will be used for prototype equipment in sodium environments. We moved on to the training center. Next year, we're starting Energy Island. So it's on a good path. It's exciting. We are a very integrated team with Terra Power. I applaud Bill Gates's vision to support this technology. He has, they're an impact investor. They're not looking for short term, but they're looking long term. Not just helping the climate non-proliferation, but also bringing forth the nuclear technology to market. I'm very excited about them.
Well, you in your job, you have a global perspective, and we see that the nuclear renaissance is expanding globally with new nuclear plants being built around the world. And I know Bechtel's providing engineering and construction services for what will be the first nuclear plant in Poland. And I'd like for you to tell us about the plans for that plant and your role there, and what does the decision for Poland to build a nuclear power plant or to add nuclear to their energy supply, what does that say about the need for nuclear power globally?
Yeah, it's a very good question, and credit to the Polish government. This is way before Russia's invasion of Ukraine. Poland had a vision to lessen their reliance on Russian gas. They had made a decision to build gas pipelines from Norway through the Baltic Sea to Poland. They had the vision to build nuclear plants, not just to reduce reliance on coal, get rid of their coal. By the way, they were at 80%. They're now at 40, 50% on coal or less than that. And, so energy security for them is vital. And then the war in Ukraine just reinforced their thinking process, solidified that. So the project that we have, it's a consortium with Westinghouse. We are doing the initial preps to build 3 AP1000 units on the Baltic Sea. It's a very large program. We opened up an office in Warsaw. We're hiring, Polish people, engineers, construction people. They're fantastic universities, really talented engineers. It's really an exciting program. Poland is obviously embracing it with the full enthusiasm. We are also committed to developing the local supply chain in Poland so that uplifting, improving capabilities and capacities so they can serve the project along with other projects in the future. So it's one of those legacy programs for us. Back in the 70s, 80s, Bechtel, along with other U.S. companies, built the Korean nuclear industry. People don't know or talk about it much, but it was the American technology and EPC companies that for 2-3 decades built what is the Korean nuclear industry today. We did the same in Taiwan and Spain. Now we're excited that we have an opportunity to do it in Poland.
Well, I think a lot of our listeners and viewers would be interested in hearing you talk briefly about what some of the unique challenges are in building a nuclear plant in a country like Poland versus the U.S. How are things different going about constructing a plant in?
So this program was conceived under an intergovernmental agreement between Poland and U.S. So there is a part of this intergovernmental agreement that supports Poland in more ways than just us building. NRC is providing support to the Polish regulator, so they don't have to do their reviews and approvals in isolation, but they can credit what NRC has done in Westinghouse's design certification and permit applications. So it's a bit of a learning process. The workforce is very productive in Poland, but we need to develop the nuclear safety quality culture, because that's what nuclear construction is all about. We're going to do it in a way that it's graded, and we don't need to build the entire site for nuclear standards. We need to build the site, the nuclear portions at the nuclear grade, and the rest of the plant, the turbine island and balancer plant, just like a conventional project. So it's exciting, it's challenging, but we have a customer and a government that is very enthusiastic about nuclear energy. And now, hopefully soon we're going to start talking about a second site in Poland.
Well, that's very good.
3 more gigawatt scale reactors.
All right. Well, Ahmet, the industry talks a lot today about workforce development, and there's a sense of urgency to ensure that there's an adequate cadre of skilled workers available for future nuclear construction and operation. Can you talk about the state of the workforce from Bechtel's viewpoint, and how concerned are you about the availability of future workers and what Bechtel's doing to help make sure that pipeline stays full?
Yes, so this is probably the biggest risk to major nuclear construction in the U.S. is the availability of skilled workforce. But then again, this is our strength. Today, we have about 20,000 craft labor under our payroll in the US. 15,000 are concentrated in the Gulf, working at 4 LNG export facilities that are under construction. So we know how to recruit, we know how to skill, we know how to retain and take care of craft professionals. We're very good at it. But when you start talking about, 10 gigawatt under construction by 2030, the numbers, you need another 20, 25,000. And today, there's a significant shortage in technicians, in electricians, in pipe fitters and welders. So we're doing a couple of things. We have a lot of initiatives, and we are in constant dialogue with the U.S. government how they can help, put more focus, emphasis, and help us mitigate this shortage. One is, more vocational training at community colleges, help develop maybe where the nuclear plants are going to be located, expand existing community colleges, provide some grants for vocational training and certifications, hire trainers, expand facilities. We started, just to set the example as a company, setting up the first one in Wyoming. We just started that. That's where we're going to be building. We are building the Natrium plant. And then we want to spread that to other states that are of interest to us. And we are encouraging the U.S. government to work with other industry and provide grants so that there are more of these facilities with trainers spread around the country where construction work is ongoing or will be planned. More importantly, and we had discussions with even the White House policy directors, we need a national campaign to make construction cool again. These are high-paying, very rewarding projects and jobs. And for some reason, in the last 2 decades, you see less and less people getting into construction. We have initiatives as a company, military veterans, women in nuclear. We're trying our best, and we are now in discussions with the U.S. government to start a national campaign. Make construction cool again.
I like it. I like this tagline. It's good.
You can take credit, Michael.
I think that's a great initiative. I did notice in some of the reading I did that this workforce development, what you're doing is extending even to Poland, where you're working on the new plant over there. That you're partnering with some of the Polish universities for workforce development initiatives.
Yes, we are partnering, especially in Gdańsk. This is the closest university to where the project site is. They are thirsty, hungry for information. They want us to help them with the curriculum's content so that their students graduate with skills that they can apply at a construction site, whether it's engineering, community colleges for vocational training. So we just started that, and we're going to be very active in Poland doing the same.
Very good. Ahmet, finally, as we kind of close out today, as a leading player in the evolution of nuclear power, what is your message, Bechtel's message to the industry? We seem to be at kind of an inflection point right now where, after decades of dormancy and lack of support for nuclear power, that nuclear is making a comeback. And what do you say to your industry peers about what's needed to make sure that this renaissance that we're talking about actually becomes a reality?
I think it's a very good question. So I joined Bechtel and my career right when the nuclear industry was coming down in 1991. We've done a lot of work at nuclear plants, but at the time we were either completing completions, restarts. The first new build was Vogtle units 3 and 4. But I grew up in the nuclear industry. I have never seen, nor I think the conditions are going to be any better than what we have today. A high demand with data center AI, a very bipartisan government with some serious incentives and loan guarantees. And, public acceptance, whatever your belief, climate, economic growth. So all the stars are aligned. The only people that we have now the responsibility to show we can do this, and that's the EPCs, that's the technology companies, that's the suppliers, the owners, utilities. So we take this very seriously because it's a big responsibility. One project fails, it hurts everyone. Mm-hmm. I don't wish a project, even in the UK or elsewhere in the world, fail because it paints nuclear with the same thick brush. My message is always, do not set expectations you're not going to be able to meet. Nuclear in the beginning is going to take longer. It's going to be a little bit more expensive. Meet an expectation we can meet, because when we meet, that's a success. If we set expectations because that's what someone else wants to hear, and then we fail, it hurts everyone.
Very good. Ahmet Tokpinar, Principal Vice President and General Manager of Bechtel's Nuclear Power Business Line. Thank you very much for joining us on the Gone Fishing podcast today.
Thank you, Michael, and thanks for giving me the opportunity.
We're very happy to have you. Thanks again.